Hi everyone. Today is the second video of paper 1 variant 2 A levels maths May June 2018. So today I'll complete this paper in this video. Let's start. Okay, question number 8. Points A and B have coordinates h and 4h plus 6 and 5h respectively. The equation of the perpendicular bisector of AB is 3x plus 2y is equal to k. Find the values of constant h and k. Okay, so we got 2 points. Point A is hh and point B is 4h plus 6 and 5h. Okay, so the midpoint of the AB line, we know the formula for the midpoint, which is x1 plus x2 over 2 comma y1 plus y2 over 2. So this is our x1 y1, this is our x2 y2. Okay, therefore by putting the values, which will be x1 is h plus 4h plus 6 over 2 comma h plus 5h over 2. So this will become is 5h plus 6 over 2 comma 6h over 2. So this will be cancelled with 3. This will become 5h plus 6 over 2 comma 3h. This is the midpoint of AB. Okay, now gradient of AB. Gradient of AB, which is denoted by m, and the formula is y2 minus y1 over x2 minus x1. So this gradient will be, by putting the values, y2 is 5h and y1 is h over x2 is 4h plus 6 and x1 is h. So which will be 4h over 3h plus 6. This is the gradient of line AB. Now we know the equation of perpendicular bisector of AB is given 3x plus 2y is equal to k. So we'll find the gradient of the perpendicular bisector by writing it in the form y is equal to mx plus c. So this can be written as 2y is equal to minus 3x plus k. It can be written as y is equal to minus 3 by 2 x plus k by 2. So the gradient of perpendicular bisector is minus 3 by 2, the coefficient of x. Now we know that AB and the perpendicular bisector, they are perpendicular to each other. Therefore the product of their gradients is minus 1. Therefore gradient of AB into gradient of perpendicular bisector is minus 1. Okay, by putting the values, what is gradient of AB? This is, I have already found, 4h over 3h plus 6. So this will be 4h over 3h plus 6 into gradient of perpendicular bisector, which is minus 3 by 2, is equal to minus 1. So this 2 will cancel this 4 by 2, and so this minus will be cancelled with this. Okay, I have to move in the next page. So this will become 2h over 3 into h plus 2. I'll take 3 as common, into 3 is equal to 1, and this 3 will be cancelled with this. So I will get 2h over h plus 2 is equal to 1, and by cross multiplying I will get 2h is equal to h plus 2, or 2h minus h is equal to 2. So h is equal to 2. This is the value of h. Now I'll put the value of h in the midpoint. What was the midpoint, which I have already found at the start? This was 5h plus 6 over 2 and 3h. So by putting the values of h here, I will get the midpoint 5 into 2 plus 6 over 2, 3 into 2. So this will become 12 plus 6, 10 plus 6, 16 over 2 and 6. So this will be 8 and 6. This is the midpoint. Okay. Now we know the gradient of perpendicular bisector is minus 3 by 2, and the perpendicular bisector is also passing through this point. So we got point and gradient. So therefore the equation of perpendicular bisector will be y minus y1 is equal to m into x minus x1. So by putting the values, y minus, this is our y1, this is the point gradient point form. So y minus 6 is equal to, gradient is minus 3 by 2 into x minus 8. By cross multiplying, 2 will come to the left, will multiply 2y minus 12 is equal to, multiply inside with minus 3x plus 24. So take 3x on the left and 12 on the right. It will be like 3x plus 2y is equal to 24 plus 12, which is 3x plus 2y is equal to 36. But in the question we are given with the equation of perpendicular bisector, that is 3x plus 2y is equal to k. In the question you can find. So by comparing, therefore k is 36, because these should be same. So this is the value of second constant k. This is the question number 8. Question number 9. A curve is such that dy by dx is equal to square root 4x plus 1 and 2, 5 is a point on the curve. Find the equation of the curve. Okay. So we are given with dy by dx is equal to under root 4x plus 1, and this curve is passing through the point 2, 5. Okay. So we can write it as dy by dx is equal to 4x plus 1 power 1 by 2 because there is a square root. So take dx on the other side. So dy is equal to 4x plus 1 raised to power 1 by 2 dx. Now, by integrating, we'll get dy 4x plus 1 raised to power 1 by 2 dx. Okay, this will become y is equal to, this will become 4x plus 1 raised to power 1 by 2 plus 1 over 1 by 2 plus 1 into derivative of this inner function, which is 4 plus c, the constant of integration. So this will become y is equal to 4x plus 1 raised to power 3 by 2 over 3 by 2 into 4 plus c. Now this will become 2 times. So y is equal to 1 by 6, 3 2s are 6, into 4x plus 1 raised to power 3 by 2 plus c. Okay. Now this curve is also passing through the point 25. So by putting point 25 in the above curve, will get 5 is equal to 1 by 6, 4 into 2 plus 1 raised to power 3 by 2 plus c. So take okay, 5 is equal to 1 by 6 into 9 raised to power 3 by 2 plus c. So 5 is equal to 1 by 6 into 3 square into 3 by 2 plus c. I'll write 9 as a 3 square. So this square 2 will be cancelled with this 2. So I'll be left with 5 is equal to 1 by 6 into 3 raised to power 3 plus c. So 5 is equal to 1 by 6 into 27 plus c. This can be written as 3 2s are, 3 9s are. So 5 is equal to 9 over 2 plus c. 5 is equal to 4.5 plus c. So c will be 5 minus 4.5, which is 0.5 or 1 by 2. So we'll put the value of c in this equation and we'll get the final equation of curve. Therefore, equation of curve will be y is equal to 1 by 6 into 4x plus 1 raised to power 3 by 2 plus 1 by 2. This is the equation of curve, which is answer of this part. Part 2. A point B moves along the curve in such a way that the y coordinate is increasing at a constant rate of 0.06 units per second. Means we are given with dy by dt. This is the rate of change of y, which is 0.06. Find the rate of change of x coordinate. Okay, we need to find rate of change of x, which is dx by dt. And when the p passes through the point, we got a point 25 as well. Okay, so we got the equation of curve dy by dx 4x plus 1 square root. Okay, by putting 0.25, we'll get dy by dx is equal to 4 into 2 plus 1. Sorry, 1 is, yes, so it will be 4 8 2 are 8 plus 1 9. So we'll get the value of dy by dx, which is 3. Now by chain rule, we know that dy by dx is equal to dy by dt multiplied dt by dx. Okay, put the values. Dy by dx is 3 and dy by dt is 0.06 into dt by dx. So take this on the left side, it will be like 3 over 0.06 is equal to dt by dx, which will give us 3 by 0.06 will give us 50. So dt by dx is 50, but we need to find dx by dt. So we'll take reciprocal of both sides. This will give us 1 over dt by dx is equal to 1 over 50. So this will become dx by dt, and 1 over 50 is 0.02. This is the answer of part 2. Part 3. Show that d2y over dx square into dy by dx is a constant. Okay. So we are given with dy by dx 4x plus 1 square root, which can be written as 4x plus 1 raised to power 1 by 2. Okay, we'll take the double derivative. Again, we'll differentiate. This will become d2y over dx square, and this will become 1 by 2 into 4x plus 1 raised to power 1 by 2 minus 1 into derivative of inner function, which is 4. So this will become 2 times. So d2y over dx square will be 2 into 4x plus 1 raised to power minus 1 by 2, because 1 by 2 minus 1 is minus 1 by 2. So this can be written as d2y over dx square is equal to 2 over 4x plus 1 square root. Now d2y over dx square into dy over dx is equal to, because we need to find the product of these two, so we'll put the values. What is the value of d2y over dx square? Which it is 2 over square root 4x plus 1 into the value of dy by dx is square root 4x plus 1. So this will be cancelled, which is equal to 2, which is a constant. So it is shown that the product of these two is a constant. That's it. This is the answer of part 3. Question number 10. Solve the equation 2 cos x plus 3 sin x for x between 0 and 360. Okay. So we are given with 2 cos x plus 3 sin x is equal to 0. Okay, take this 3 sin x on the right side. 2 cos x is equal to minus 3 sin x. So take 3 on this side and cos on that right side. It will become minus 2 by 3 is equal to sin x over cos x. So it can be written as minus 2 by 3 is equal to tan x. We know that sine over cos is a tan. So this can be written as tan x is equal to minus 2 by 3. Okay. So x is equal to tan inverse minus 2 by 3. So our alpha will be tan inverse minus 2 by 3 is actually 33.7. This minus is just showing that the tan is negative. So we'll just consider the value of angle only. Now draw the quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. Since tan is negative, it means the tan is in second and fourth quadrant, like that. So these are our alphas, 33.7, 33.7. So theta will be, first theta will be this one, and the second theta will be this one. So the two angles will be, therefore theta will be 180 minus 33.7, which is 146.3, and the second theta will be 360 minus 33.7, which is 326.3. So these are our two values, roots of this equation. So they are the answers. Part 2. Sketch on the same diagram the graphs of y is equal to 2 cos x and y is equal to minus 3 sin x for x between 0 to 360. Okay, this is the axis, x-axis and y-axis, on which we'll plot the graph. I hope all of you knows how to plot the graph. I can write it as y is equal to 0 plus 2 cos x. It means 0 is our baseline, which is x-axis. And I can write it as y is equal to 0 minus 3 sin x. So I'll not go in detail, I hope everyone knows. So this is also the baseline. 0 means x-axis is the baseline. So both graphs will be plotted on the x-axis. Okay, first of all we'll divide the we need 5 points. Let's suppose this is 360 and this is 0. The mid of these two values is 180, and the mid of 0 and 180 is 90 here, and the mid of 180 and 360 is 270 here. So we need these 5 points. Okay, first of all I'll plot the graph of cos x. This 2 is showing the amplitude of the graph, means 2 points above and 2 points below the x-axis. So for your convenience, always draw the dotted line so you can easily identify where you have to plot, like this. So here are the dotted lines. As you know, cos always started from the maximum value. This is the maximum value, so at 0 this will be here. Cos is 0 at 90 degrees, and cos has the lowest value at 180, which is minus 2, then again 0 at 270, and highest value again at 360. So we got 5 points. Okay, so the graph will be like So this is the graph of y is equal to 2 cos x. Now we'll plot the graph of sine x. So this 3 is showing that this is the amplitude of the graph, 3 points above and 3 points below the x-axis. So I'll repeat the same process. I'll draw 2 dotted lines at the boundary points so that it will help me in drawing the graph like this. So these are the dotted lines. Okay, now the sine will always, the graph of sine will always start from 0 because sine 0 is 0. But please be careful. You got -3. It means the graph will flip over. Usually the sine graph goes like this. Okay, this is positive and this is negative, but this minus is showing that our graph will flip over, so it will be like this. Okay, so the values of sine at 0 is 0. So at 90 the value will be the lowest one, which is -3, and 180 again the values will be 0, and at 270 the value will be the highest value, which is 2 plus 3, and then at 360 the value is 0. These are the 5 values of the sine graph. So the graph will be like this. So this is the graph of y is equal to -3 sine x. Okay, now these are the 2 graphs. Part 3. Use your answer to the part 1 and 2 to find the set of values of x for which this is greater than 0. So we are given with 2 cos x plus 3 sine x is greater than 0, or we can write it as 2 cos x is greater than, take sine x on the right side, it will be -3 sine x. Now you can see the 2 cos x is greater than -3 sine x. So the values of x will be that portion of the graph where the cos graph is above the sine graph, because 2 cos x is greater than 3 sine x. If you see the graph carefully, look at this. This graph is above the sine graph until this point. So this is our first value, which is 146.3 degrees, because you can see this value from the last part, from previous part, and again now from this point right onwards the sine graph is above, so which is not our solution until this point. At this point the cos graph again is above the sine graph, so this value is 326.3. These 2 values I have already calculated in the previous part 1. So this is our answer, this and this, because from this point rightwards the cos is above the sine x, and from this point leftwards the cos graph of cos is above the sine graph. So our answer will be x is greater than 326.3 and x is less than 146.3 degrees. So these are our answers. The last question, question 11. The diagram shows a part of the curve y is equal to x over 2 over 6 plus 6 over x. The line y is equal to 4 intersects the curve at point P and Q. These are the 2 points. Show that the tangents to the curve at P and Q meets at the point line y is equal to x. Okay. So first of all, we need the coordinates of P and Q. For this, we got the curve y is equal to x over 2 plus 6 over x, and y is equal to 4. So we'll solve these two for the values of x. So put y is equal to 4 here. 4 is equal to x over 2 plus 6 over x. I have to squeeze my question because I have this much space only, and look at the total marks. This is very unfair. They should give extra space because the space should match the total value of the marks. So I have to squeeze a bit. Okay, take the LCM here, 2x 4, so it will become x square plus 12. Now by cross multiplying, it will be 8x is equal to x square plus 12, or I can write it as x square minus 8x plus 12 is equal to 0. So by midterm break method, I will come up to x minus 6, x minus 2 is equal to 0. So it will be x is equal to 6 and x is equal to 2. So I got y is equal to 4 and I got two values. It means the point P is 2, 4 and the point Q is 6, 4. So these are the 2 points. This is 2, 4. This is 6, 4. Okay. Now, I need to find the equation of tangent at P. For this, I need to find the gradient of the curve at P, which I will get by differentiation. So I got y is equal to x over 2 plus 6 over x. So I can write it as y is equal to x over 2 plus 6 into x raised to power minus 1. So dy by dx will be that will be 1 by 2 plus 6 into minus 1 x raised to power minus 1, which will be dy by dx is equal to 1 by 2 minus 6 over x square. Okay, putting point 0.24 because the gradient is passing through point P, so we'll find the value of the gradient, which is tangent, value of tangent. So this will be dy by dx 1 by 2 minus 6 by 2 square. So I'll start my part here. So this will be dy by dx is equal to, after simplification, minus 4 over 4, which is gradient of tangent at P, which is minus 1. So equation of tangent at P will be y minus y1, the point. This is the point where the gradient is passing. So y minus 4 is equal to m, which is minus 1, x minus 2. This is the point gradient form. So this will become y minus 4 is equal to minus x plus 2. Take x on the left and 4 on the right. So x plus y is equal to 6. This is equation number 1. This is the equation of P. Now at Q, which is 6, 4, again I have to repeat the process. I have to find the gradient of the curve at this point, and then we'll move further. So for this, dy by dx, I have already found dy by dx, which is 1 by 2 minus 6 over x square. So put the value here. Dy by dx is equal to 1 by 2 minus 6 by 6 square. So after simplification, I will get the gradient at Q a 1 over 3. So equation of tangent at Q. I have to squeeze my question, which is again y minus y1. So what is y1? This is 4. So y minus 4 is equal to m. M is 1 by 3. 1 by 3 into x minus x1, which is 6. So by cross multiplying, 3 will come to left and multiply. 3y minus 12 is equal to x minus 6. So take 3y on the right and 6 on the left. It will be minus 12 plus 6 is equal to x minus 3y. So I can write it as x minus 3y is equal to minus 6. This is equation number 2. So now I got two equations. This is 1, this is 2. I'll solve them simultaneously to get the their point of intersection. So from 1 I can get from 1 I can get y is equal to 6 minus x. Okay, so I'll put the value of y from this to this one. This will become x minus 3 into y means 6 minus x is equal to minus 6. X minus 18 plus 3x is equal to minus 6. So this will be 4x is equal to minus 18 plus 18 minus 6. 4x is equal to 12. X is equal to 3. So I'll put this value of x in here. So y is equal to 6 minus 3, y is equal to 3. So their point of intersection is 3, 3. It means the value of x and value of y is same. So this is the proof that they meet at the line y is equal to x. Therefore, they meet at line y is equal to x. This is shown. Okay, so look at the space and the amount of work which I have to do. Okay, second part, find showing Gaussian acid working. The volume obtained by the shaded region is rotated 360 degrees about x-axis. Give your answer in terms of pi. Okay, for this we need to see the figure first, and I'll explain how we can find the volume of the revolution by rotating the shaded region around 360. So if you see the question carefully, if I make this line, so just forget this shaded region first. If this rectangle will rotate 360 degrees, it means it will be a cylinder with the radius this much, r is 4 and height is 4 as well. So first of all, I'll find the volume of this cylinder, then I'll find the volume of this white part, and in the end I'll subtract the volume of this white part, which is the area under the curve, from the sphere, from the cylinder. Then I'll get the final answer. So this question is actually in two parts. First, I'll find the volume of cylinder, then the volume of revolution of this white part. Okay. So number one, volume of cylinder, which is pi r square h, and I have already explained r is 4 and h is also 4. So this will give me 64 pi. This is the volume of cylinder. Now I have to find the volume of white part, which is area under the curve. So volume of revolution under the curve, the formula is pi y square dx, and the boundaries will be from 2 to 6, because if you see the figure, our shaded region is from 2 to 6. Okay, so this will be like pi 2 6. What is y? Y was x over 2 plus 6 over x, so its square will be x over 2 plus 6 over x whole square dx. Okay, we'll open the square first. 2 6, this will become x square over 4 plus 36 over x square plus 2ab, mean x will be cancelled with x, 2 will be 2, and I will get 6 here, dx. Now I will integrate. So this will become x cube over 3 into 4 plus, and I will take x on the x above, it will be x minus 2. So this will become 36 x minus 2 plus 1 over minus 2 plus 1, plus the integration of 6 is 6x 26. Okay, now this will become x cube over 12, minus 2 plus 1 is minus, this will be minus 36, this will be also minus x raised to power minus 1, which will be over x, and plus 6 x to 6. Okay, now put the values. First I'll put 6 in all three terms, then 2. This will become 6 cube over 12 minus 36 over 6 plus 6 into 6, which is 36, minus, because now I'm going to put 2 all over. So 2 cube over 12, because the minus is outside, so this will be plus 36 over 2 minus, this will be minus 6 into 2, 12. So pi, this will become, after calculating with the calculator, this will be 18, this will be 6, 36, this will be 8, so this will become 2 by 3, this will be 18 minus 12. So by solving all these terms, this will be like 54 minus 2 by 3, take LCM 3, so this will be 162 minus 2, which is 160 over 3 pi. This is the volume of white part. So the volume of shaded region will be therefore volume of shaded region will be volume of cylinder, which is 64 pi, minus volume of this this white part. So by taking LCM, it will be 192 minus 160 pi, which is 32 over 3 pi. This is our final answer. So that's it, end of the paper. Thanks for watching, and see you in the next video, which is in which I'll discuss the paper 1 variant 3. So thank you very much.